You ever wonder how we know things about millions and millions of people without actually asking every single one of them? I mean, it sounds impossible, right? But it's something that happens every single day, and it's all about making a really, really smart, educated guess. Today, we're going to dive into a true cornerstone of statistics, estimation. Okay, let's just jump right in with a massive question. How on earth would you figure out the average age of an entire country's population? I mean, really think about that. We're talking millions of people. Where would you even start? It's a huge task. Well, the short answer is you can't. You just can't ask everyone. It's totally impossible. But this is where statistics gets really clever. It offers this amazing shortcut. Instead of even trying to measure the whole population, we can just study a small, well-chosen group, what we call a sample. And from that small group, we can make a really smart guess about the whole shebang. That's the core idea of making an inference, using a little bit of data to understand a whole. Okay, so before we can start making these smart guesses, we've got to get on the same page. We need to be super clear about what we're actually measuring. So let's get our terms straight, because this is literally the foundation for everything we're about to talk about. All right, there are two big ideas here you absolutely need to get. First, you have the population parameter. Think of this as the ultimate truth, the hidden treasure we're searching for, like the actual true average age of everyone in the country. The thing is, we can probably never know it directly. What we can find is the sample statistic. This is our best guess, right? It's the number we calculate from that small group we actually talked to. The whole game, the whole point of this, is to make our guess, the statistic, as close as we possibly can to the real truth, the parameter. And this is actually pretty cool. Statisticians have a clever way to keep track of this difference. They basically use a secret code, different symbols. So if you ever see Greek letters like mu or sigma, that's their way of saying, hey, we're talking about the real, true value for the entire population. But if you see regular old letters like X bar or lowercase s, that's a huge signal that they're talking about an estimate from a sample. It might seem small, but it's a really crucial distinction. All right, so how do we actually go about making this guess? Well, the simplest, most straightforward way to do it is something called point estimation. Point estimation is, exactly what it sounds like. You're giving one single number as your best possible guess. It's just like pointing to one tiny spot on a map and saying, the treasure is right here. No messing around. It's simple, it's direct, and it feels super decisive. So, for our example, after we survey our sample group, we make our point estimate. We stand up and we declare, okay, our single best guess for the country's average age is exactly 28. See? Clean, simple, and right to the point. Now, for a single guess like 28 to be any good at all, it has to play by two really important rules. First, it's got to be unbiased. That just means our sample has to be a fair mix of the whole population, not just, young people or only people who live in cities. It has to represent everybody. Second, it has to be consistent, and that's a simple idea. The more people we ask, the bigger our sample gets, the closer our guess should get to the actual truth. Makes sense, right? But, and this is a big but, there's a huge kind of hidden problem with being so precise. Pointing to one single number feels really confident, doesn't it? But it has a massive, massive flaw. I mean, just think about it for a second. What are the chances that our guess of 28 is exactly right? Not 28.1, not 27.99, but perfectly exactly 28. When you're talking about millions of people, the probability of our one little number being the perfect, true value is, well, it's practically zero. It's almost impossible. And that brings us to the crucial point, reliability. How much can we really trust that single number? A point estimate gives us zero information about how confident we should be. It doesn't tell us if we're probably really close to the truth or if we could be way, way off. It feels precise, but really, it's a false precision. So, you see, the problem isn't really the guess of 28 itself. The problem is the false sense of certainty that a single number gives you. It looks so strong and confident, but in reality, it's incredibly fragile. So, if pointing to a single number is like trying to balance on a pinpoint, what's the answer? We need something better. We need a safer and, frankly, a more honest way of making a guess. The solution? We need a range. And this brings us to the hero of our story today, interval estimation. This is a much, much smarter and more useful approach. So instead of just giving one single number, interval estimation gives us a range of values. It gives us a low end and a high end. We're not saying the answer is 28. Instead, we're saying
we're pretty sure the answer is somewhere inside this range. It's like giving ourselves a statistical safety net. So instead of that bold claim that the average age is 28, we can say something way more powerful and, honestly, more believable. We'd say something like, the true average age is likely somewhere between 27.5 and 28.5 years. And this side-by-side really makes the difference crystal clear, doesn't it? A point estimate is precise, yeah, but it's probably wrong. It's like trying to hit a tiny little pin from 100 feet away. An interval estimate, on the other hand, says the answer is likely between two numbers. It's more reliable, it's more informative because it's honest about the fact that we're not perfect. It builds in that wiggle room.
Okay, so what's the big deal? Why does this all matter so much? Let's get to the most important takeaway here, which is why this shift from a single point to a whole range is so incredibly fundamental to how we understand the world around us. It's because you see this concept everywhere once you know what to look for. That election poll that says a candidate has, say, 45% of the vote, plus or minus 3%, yep, that's an interval estimate. A medical study reporting how effective a new drug is, they give you a range. This method is the absolute bedrock of trustworthy statistics, precisely because it's built on being honest about uncertainty, instead of pretending it doesn't exist. But of course, this leads us to one final, really important question. If we're going to provide a range, how do we measure how confident we are that the real answer is actually in that range? I mean, are we 90% sure, 95%, 99% sure? How do we calculate and talk about that level of confidence? Well, that is the perfect question to set us up for our next discussion.